Good afternoon. I'm Shoshana Hus from Sysgem AG. Sysgem is a Swiss-based software development company, and I work in marketing in our German office. The subject of our presentation this afternoon is securely managing VMS from a Windows environment. During this presentation, I will describe the objectives that we set out to achieve when we first started to design our multi-platform product for system management. We named the product Sysgem Enterprise Manager, and we abbreviated to SAM. Later, my colleague Mike Schofield from Technical Support in our UK office will demonstrate some of the topics we have discussed. We will outline the SAM architecture, the security considerations we made during its design, and we will give examples of its use with VMS systems. The first part of the presentation will last around 10 minutes. The second part will last around 30 minutes. And then we'll be happy to take any questions. First, the objectives we set ourselves at the outset of the project. Delegation. Have you ever known a system manager with time to spare? One of the primary objectives of Sysgem Enterprise Manager was to provide a secure system whereby routine tasks can be offloaded from busy, technical, and therefore expensive system managers and assign those tasks to other less technically experienced individuals in the organization, such as help desk operators. Since the primary users of SAM were to be help desk operators, user administrators, security managers, etc., we wanted the user interface to be intuitive, non-technical, and be available on users' desktops. Since Windows is the prevalent operating system for workstations in a commercial environment, we chose a GUI interface on the Windows platform. Authorization. In the SAM architecture, we created a central software component that we call the SAM Authorization Server, which is the focal point for SAM security. It is used for the authorization of SAM users and for the management of SAM software. It is also used for the signing of messages before transmission to SAM software on remote managed servers, and it is the default location for the audit trail and other SAM databases. Users log into SAM using software on their Windows workstation and have their SAM credentials validated by the authorization server. A SAM user account held at the authorization server holds a profile for permissions that determines the level of access for individual users. It is possible to set the level of access to a very fine degree of granularity. For instance, all help desk menu options can be hidden or revealed according to the profile settings. Access to nominated groups and/or users can be granted or denied. Communication with certain target servers can be approved or disallowed. Turning our attention to the software components that run in these locations. At the user's workstations, we have the SAM client component. This component provides all the graphical user interface to the user. At their central Windows server, we have the SAM authorization server component. This component is the central secure location for validation of SAM user logins, a repository for user permissions, all script and user interface libraries, Audit and other databases, and the SAM certificate authority. At each target server being managed, we have the SAM agent component. It is kind of a script processing engine. It communicates with the SAM client, it receives and executes scripts sent by the client, and it returns output to the client. Software management. All scripts that run on target machines are held in one location, at the SAM authorization server. Updates to scripts and the customization of scripts are concentrated in this one central location. Scripts appropriate to the transaction type are transmitted with every communication message from the authorization server to the remote managed servers. So software upgrades are self-propagating from the central authorization server to all remote managed systems. Message signing. For security reasons, all transaction messages used in the SAM network are first signed by the authorization server. Unsigned or incorrectly signed messages will be rejected by recipient software components. So for example, a transaction to update a user account on one or more target VMS servers is first sent from the SAM client to the authorization server for signing. The signed message, together with the appropriate processing script, is returned to the client and forwarded to the agents running on the target VMS servers. The input data plus the scripts required to process the transaction are all signed to ensure that no interference is possible. SAM databases, such as the SAM Audit Trail database, can be located in any location since they are accessed via Open Database Connectivity, ODBC. But by default, they will be centralized at the authorization server, and it is here that the software calls are made to write to the databases. Secure Network Protocol. An installation option allows SSL or TLS to be used for network security. If a customer prefers, for example for legacy systems where SSL is not available or not convenient to be used, an alternative communication security mechanism is available for installation with SAM. If SSL is being used, then all communication connections between the SAM software components are transmitted via SSL. Audit Trail. An audit database is maintained at the SAM authorization server that gives all information available to us regarding all help desk user account admin transactions. For instance, it records the following: date and time of the transaction, the identity of the SAM user who conducted the transaction, the identity of the target server and the target object, for example, a user account ID, the nature of the transaction, such as create, modify, delete, enable, disable, etc., the details of the input submitted, except for passwords, of course. We never record typed passwords. If the transaction is an account modified transaction, then the before and after states of the fields modified are shown. We show the content of the field before it was modified, and we show the content of the field after it was modified. The identity of the Windows user account used by the SAM user to log into Windows on the workstation, and the identity of the workstation used by the SAM user. SAM provides an audit browser which can be used to search for specific auditable events and export audit records into a number of different formats, including HTML, Word documents, Excel spreadsheets, etc. Target platforms. Not only are VMS servers managed and monitored, but so too are Linux, Unix, Windows, and OS 400. Since this bootcamp is an OpenVMS bootcamp, our demonstration will predominantly use the VMS platform. If someone wants to see the product in action on one of the other platforms, please come and see us at our stand. Finally, customization. And an important objective for the project was to allow customers to view and, if required, to modify all scripts that run on target servers. Also, to be able to change all input forms in the user interface, allowing a completely customized view of the product and of the actions it takes. Accordingly, the objective was for the entire system to have an open architecture. It was also an important objective to allow customers to write their own applications that run within the SAM framework. SAM provides the tools for building those applications by interfacing to the SAM framework. Equally important was to protect a customer's investment after he made changes. SAM is allowing any changes that are made to be automatically carried forward between versions when software from Sysgem is upgraded. Mike will demonstrate these techniques later. Our ability to delegate routine tasks away from the overworked and expensive system manager to the help desk saves money on manpower resources. Additionally, the product is easily maintained using the centralized architecture of SAM. If anyone has any questions or needs further information after this session, we have a sponsors table open at Ashwood Court, just outside this conference room. I will now hand over to Mike Schofield, who will demonstrate some of the features of Sysgem Enterprise Manager.
Thank you, Shoshana. So, Shoshana described the agent that runs on the target servers as a script processing engine. And actually that's an important concept to bear in mind for this demonstration. All transactions start at the workstation and are transmitted to the servers via the authorization server. Now actually, the transaction that's transmitted not only contains the input data that's been keyed at the workstation, but it also contains the script which is used to process that input data. So the agent takes the message, executes the script, and then sends the results back to the workstation for display. Right, so I'm going to start the demonstration by showing a very simple system management tool within SEM. We call it the task scripts. And actually a task script is a very good demonstration of that transaction cycle that I've just shown, because it allows the system manager to type into a window on the workstation, to type DCL commands into a script, and then have those scripts executed on potentially multiple remote VMS systems, and then have each of the agents process those scripts and return the results of the processing for display back into the window on the workstation. So I'm going to begin with a task script which I showed earlier. And for the purpose of the demonstration, it's a very simple, really just a one-line script, which is the show system time. I've also got a set verify here because we automatically add a set no verify when we are processing scripts. So to show what we've actually been doing, I've included a set verify command in front of the show time command. And then I pick the agents on the servers which are going to be running this script against, and by default it picks the machines which I last ran this script against. I could pick other scripts, other agents, but I won't. I'll just run it on these two. So I press start. The script sent down to the two agents. The script is processed. The results come back into the results window at the top of the screen, and here I can see that the two servers have returned the system time as produced by the show time command. So that was a very simple task script, but it got over the point that here I can create at the central system a task script and then have that script transferred down to the target systems and executed, and the results shown back on the workstation. But I can make a task script more flexible by adding parameters. I'll demonstrate that by creating a new task script, a new entry, and I'll give it a name. I'll call it VMS directory, and I will add a parameter. I'll just add one parameter, and I will give that parameter a title. I'll call it file name, and also give it a code. It's a 2-character alphabetic code, so I'll give it a code of FN for file name, and that code's important because the script will refer to the content of the parameter relative to that code. And what we do is to put the whatever is typed into the parameter into a DCL symbol, and the DCL symbol has got this 2-character code. So it has a name of input underscore and the 2-character code. So it's input underscore FN in this case. Create the parameter, and now we'll go down and create the actual script that's going to run with that parameter. Do the same sort of thing with the set verify, and now I'll do a directory of the content of the DCL symbol input underscore FN. Click OK, and click OK again. So now I can see that the task script that I've just created has been added to my library. I will double click on it to start it. There are no agents selected because this is the first time I've run the script. So I'll select an agent. I'll select the Sales2 agent, and then I'll start the script, and it will instantly put up a pop-up window prompting me for the file name for the parameter. And in the first instance I'm going to leave that parameter empty and just run it with a directory and an empty DCL symbol. So what it does actually is to display all the files in the default directory in that on that server. In fact, this is the default directory of the agent that's processing the script. Now I can export that information. Export it as a text file. I can select just one of those files, and I'll copy that file name into the paste buffer. I don't need this anymore. Then I'll restart the script, and this time I'll add the parameter, the file name, so I've saved in my paste buffer. I'll also add a qualifier of /full, so it's going to give me a full file specification for this particular file. Click OK, and again the script is transferred down to the agent, and it shows the details for that particular file. Cancel that. So that's the task scripts capability. System Manager can actually have as many task scripts in his library as he wishes. He can also import DCL scripts that he's already got and keep them as an item within his library. And the advantage here is that instead of keeping the DCL scripts on the individual servers and having to keep multiple copies potentially of those scripts everywhere, he can hold one copy of it in this central location, and then simply when he runs it select which machines he wants to run it on this occasion. And also a system manager can share his library with other system managers on the same system. So you've got, if you like, a centre of expertise where people can share the task scripts that they've produced. Okay, so that's task scripts. Sysgem ships with a number of displays, and I'm going to just show one or two of those. The first one I want to show here is the File and Directory Explorer. Start that one. Again, I'll run it against the two machines, the i64PS and Sales 2. And what this is doing is now giving me a view of the file structure. It's a very similar sort of view as the Windows Explorer, but the target machine or VMS systems. And here I can see if I browse down and drill down into the file and directory structure on the VMS system, I can see the different files and directories there. I can edit files if they're a text file. So here I've got a text file, it's a command file. If I double click on that, then what I'm now doing is within the Notepad editor on my Windows system, I'm editing the VMS file that's located on the target VMS system. I can make changes here, I can save those changes, and I'll then get a new generation of that file on the target system. So I can create new files, I can delete files, I can rename files. I can even copy one file from one machine into another machine, and it will retain the file attributes for that file as it gets copied across to the new machine. That's the File and Directory Explorer. Whilst we're in the context of Explorer windows, there's another window here, another Explorer window, which I want to show you, which is the Queues Explorer, VMS Queues Explorer. Double click on that, and again I shall use the same two machines that I've connected to before. So it's now doing a queues exploration of the queues on those two systems, and if I drill down into here, I can see the different queues that are available on those two servers. I can select a particular job that's on one of those queues. I could then do all the things that you can do with the queue management system within VMS, but here I'm doing it from a GUI interface on the workstation. For instance, I could put a job on hold. If it's already on hold, I could release it. I can change its priority, I could delete it, etc. And again, I can just drag and drop one job from one queue onto another queue within the same machine. And I can also start and stop queues and create new queues and all the things that I can do with the queue manager on VMS I can do here from this GUI interface. The Queues Explorer. We're often asked about user account management, and here we have a window that we call Enterprise Accounts. Let's start that one. Here I'll connect to 3 machines. So I've got the 2 that we identified that we've used before, and there's a third one. These are actually physically located in Florida, and here we're doing management of user accounts on these particular machines. In the startup window, I can identify the user that I want to load into the Enterprise Accounts window, the user account, And I can identify that with either the account name or the full name or a comment field, etc. And I can do a partial match, etc. Or if I leave the field empty, then it will simply go down to those 3 machines and return all the accounts that are on those systems. So that's what I'll do. Click OK, and it now returns all those user accounts from those 3 systems. And if you notice in the bottom right hand corner of this window, it's telling me that there are 784 lines of information in this display window. And since this is the user accounts window, then it means there are 784 user accounts on those 3 servers. I can search for a particular account after I've loaded all the accounts by using the find option at the top here. I can pick, for example, the username field. I can type in some characters from the username. And in the top banner of this window, this search window, it tells me how many hits I've found with the characters I've typed so far. So I can see that there are 10 accounts that have got this text string of SCHO in the username, 10 out of the 784. I click on the apply button and it will now filter that list of accounts so that I'm only looking at those accounts which satisfy the search criteria I put into this window. I'll remove that. When I filter, actually all we do is to hide the ones that don't match the criteria, which means if I remove the filter, then instantly I get the list of all the accounts that were there before. I've also got filters that ship with the products as permanent filters, and here's one that's looking at privilege accounts. So I'll double click on that, and that applies the filter. So if the account has got system privileges or set privileges, it's got raised privileges of any sort, then it will now show the list of accounts again that satisfy that filter criteria. And I can see here that there are in fact 158 user accounts that have raised privileges on those 3 systems. I can also sort the information. So by clicking on the column title of any of the columns, it will sort the information on those columns. And here I've got the last login date. I've clicked on that. At the top of the list come those people who have logged in today, and at the bottom of the list come those people who've never logged in. And somewhere in the middle I have accounts which haven't logged in for a long period of time. So I can see here that on the status column, this is showing me with a green tick those accounts which are enabled. A red cross means the account is disabled, so the people can't log into it. But there are quite a few accounts here with a green tick, and these accounts that I'm identifying, these accounts have not been logged into this millennium, and yet they've got full system privileges and they are enabled. So the question is, why do these accounts need full system privileges when their owners haven't logged into these accounts this millennium? And often the reason is that the people have left the organisation. Because if somebody called Smith leaves the company, then does the system manager then go around all the systems looking for the account called Smith and deleting it or disabling it? And of course the answer is no. And so you will often find that there are accounts like the Mike Goodwin account here, where the person no longer works for the organisation, but they still have an account, and that account is still fully active, and it has full system privileges. If I double click on an account, it will then modify that account, go down to the target system and retrieve the fields of information that belong to that account. And here I can see, for example, that the Privilege, this person has got full system privileges, all the privileges that matter anyway, syspriv and setpriv, etc. This person's also got proxy access, so not only can they do things within this one machine, but they can have proxy access to the other machines. And when this person's logged in, they can do what they like because they've got full system privileges. So very often, when we go to a customer site, we will do exactly this thing that we just do. With just a few key clicks, we can identify those old accounts that perhaps should not be still enabled, that should be disabled or even deleted. And just with a few key clicks within the Enterprise Accounts window, we can identify a fairly serious security breach where these accounts are still there, still in existence. We can do multiple actions upon items, so having selected a group of user accounts, so if I select Steve Duke and I select Mike Goodwin and I select his demo that belongs to Mike Schofield, etc. I can now bring up a menu item and take, in one transaction, take action upon that multiple selected list of accounts. So I could disable all those accounts in one transaction. I'll not do that because I'll leave them for the next demonstration. Okay. So doing things on multiple accounts, I can also not only disable and delete multiple accounts that I've selected, but I can create an account on multiple machines, again in a single transaction, where, for example, if I were to create an account called, I don't know, bootcamp, just make it bootcamp, and if I put this on, let's say this one, these two machines, so applying defaults will take whatever information I've already typed into that form, and then it will allow me to create on those two machines a person with a username, an account with a username of bootcamp. It's also, when I click on the apply defaults, applies other defaults, like for example, it will pick out of the group 200, it will pick the next available member, so that's available on both those systems. So here I can see the next available member is 737 within group 200. And it will also do things like creating the directory name, the home directory name, and so on. Now, I can also have a template that will apply different values, perhaps the device name, for example, or the group that the person should be in. I can save all the fields within a form into a template and then subsequently apply that template when I'm using the create form. And by doing that and then applying the apply defaults button on the first page, then that will very quickly enable me to create an account, a unique account that's available on all the systems, and it will put them into a unique UIC group, a member, with the same member on both the systems I'm creating it for. I'm not going to create that. Okay, so that was the user account system. I will also look at other display windows. We have windows which automatically refresh, and they're very good for monitoring. And with the monitoring window, I might want to apply an alarm and set in the alarm a threshold, and when that threshold is exceeded, the alarm would trigger and it would take some action. let me start again with a very simple example. I'll take the disk usage window. Again, I'll start it on these two systems. It now explores and finds what disk devices are available on those systems. It gives me the device name, it gives me the type of device, the size of the disk, the amount of disk space used and the percentage used, etc., the size in blocks. And if this information is being displayed as a textual information with a percentage, I can also show that same information as a graph, as a chart. Before I do that, I want to show you the alarms that I can put onto here. So I will click on the alarm button. I will pick just a random alarm. Here I've got a disk space of 75% used. So this is looking for, if you look at the criteria field, it's looking for a disk which has a greater percentage utilization than 75%. So the threshold here is set at 75%. And of course this is only an example for disk spaces, but it could be on any criteria, any information that we're bringing back into the display window. And when that criteria, when the threshold is exceeded, then it will take an action. And here I can define what action it will take. I might want to run a script and send an email message. If I'm sending an email message, I'll want to identify who should receive the email when this when this alarm triggers. So I'll add a username, an email recipient name in there, and I can define the time of day and day of the week when, if the alarm triggers during that period of time, then it will send to this particular user. I can have as many recipients of email when the alarm triggers as I wish, and I can define for each recipient when they would receive that email, if the alarm triggered during a particular time of day or day of week, etc. You can also run scripts on the target machines. So here on VMS, I can send a DCL command script down to the target machine that generated the alarm and do some action to correct the alarm. An example of this was a customer we had in the UK that was they were running the lottery for the UK, and they had a particular requirement that when during particular times of the day and day of the week, when the lottery was being drawn, it was part of the regulation that nobody should be logged into certain machines. So we had a display window, a monitoring window that would look for logged in users, and if there were any logged in users, and if it was at a particular time of day of the week, then we could run a script which would send a broadcast message to those people who were logged in to say they really ought not to be logged in and they ought to log out pretty quick. And we could then follow that up with a subsequent script if they didn't log out and do a forced log out, etc. So that's an example of running a script as a result of an alarm triggering. Having a look at the chart information I mentioned earlier, any window that displays a percentage value, such as this percentage used in here, can be viewed not only as a textual information, but can be viewed as a chart information, chart format. And on this one, I'm looking at the percentage utilization of the CPU by the top 5 processes on this particular system. And here I can see that the system is quite happily going along using just a very small amount of CPU, and then suddenly at a particular point in time the CPU jumps up to 60% utilized. So what was it that caused that sudden increase in processing? And what I can do is to hover the mouse. If I click on the information icon over here, and then hover the mouse over any point in the chart, I can see exactly what is going on at that point in time. So here I can see that actually it's running a batch job, and indeed that's an expected one. It was at 3:30 in the morning, and it's taking a backup of the system, and that backup lasted for about 10 minutes, and during that time it used a considerable amount of the CPU, 60%. With this window, with all the monitoring windows, we can run it not only interactively, as I'm doing now, but we can run it in background mode, which means that nobody needs to be logged in for the windows to be being run. And of course the whole point of this is that we can now set alarms on different windows, have them run in background 24/7, and even though there's nobody actually using SEM to do the monitoring, the alarming is still taking place. So with this particular window we can have it set up to automatically archive the information into a file, and then subsequently I can browse that file and find out, for example, what was happening at a point in time on a particular day, and what processes were running. So we might find, for example, that last Friday there was a problem on a particular machine, nothing was working, email wasn't being delivered, etc. So by looking back at the CPU utilization charts for that particular day on that particular machine, we can identify exactly what process was causing the problem on that particular day. Okay, so that's the monitoring and alarming. I think finally what I want to do is to look at the customizability of the product. And if I start off by looking at the enterprise accounts window, if I have enough privileges within SEM, I can have a look at all the scripts which are run whenever I run one of these windows. So down here I've got the scripts that run on the different platforms. It's a multi-platform system, so this is the script which runs on the agent to gather all the user accounts on the VMS target servers. So when I got a list of those 784 user accounts, this was the script that was actually running on those servers, being processed by the agent to gather that information and return it back to the workstation. If it was a Unix system that we'd connected to, then it would still gather the same user accounts from those systems, and it would put it into the same display window along with the VMS accounts, and this is a script that would be executed on Unix systems. In Unix it's written in Corn shell. In Windows it's written in Perl. In AS400, OS400, it's written in CL, command language for the IBM system. Now we also have pre and post processing scripts which happen on the workstation, which are run on the workstation before and after the script runs on the target system. So for example, in the post processing I could take the output that came from the VMS system and reformat it, and perhaps filter it as well. Filter it, reformat it before the information is displayed into the display window. The menu items that are available are all defined here as well. So this is the create multi-platform window that I showed you, and it shows all the fields which are in the form. Have a look here at the username field. Here I can see that the code is UN, so all references to entries which are made into this particular field are done on VMS through the DCL simple input underscore UN. The scripts which are executed are down here. Again, we've got pre-processing and post-processing. In pre-processing, this happens before the script is transferred to the agent, and this menu item is create multi-platform. So in the pre-processing, we can have access to the key data and, for example, do validation. And if there's a problem with the input data, then the pre-processing script can flag that error, can pop up an error message and ask the user to retype a particular field before the transaction is sent to the agent. And again, the different operating systems have different languages for the scripts which are being executed, and these are the ones then that happen down on the agents, the VMS, Unix, Windows, OS 400, etc. It's also, if I just have a quick look at the, if I edit this window, we include, at strategic points in the system, we include these 2 lines of code, and there are actually many thousands of them in all the scripts within the Sysgem Enterprise Manager. And these 2 lines of code are replaced at runtime, and they're replaced with information that the customer can put into, we call it into an include file, and it means that at these strategic points the customer can include their own code to do some modification to the processing of the transaction. And whenever we do an upgrade of the SEM software, we never change any values in the include file, in the customer include file. And it means that somebody can make a change to the scripts, do a customization to meet their own particular needs, and they can still go out and get a new version of the software, and their customization remains intact, because we, as I say, we don't update the include file, and the whatever changes they've introduced, they continue to survive an upgrade of the system. Okay, so that was customizations, and actually that's the end of the presentation. And just as a way of summary, then what we've looked at here is Sysgem Enterprise Manager. It provides a secure and centralized and customizable system management framework, a client-server framework for the management of remote multi-platform servers. Thank you very much, and we'll now take any questions if anybody has any. Thank you.